remind me that there's no SIM card in it. So when you take it home, you're going to find SIM card and put in the SIM module. That is SIM module. Okay, so let's start the class. So as the class continues, we'll be doing all of the mentioning and the explaining. I don't know, somebody will help us with turning this. I mean, yeah, you help us with it.
Yes.
Okay, so you are going to start. Okay, no wahala. Alright, welcome guys. Then you can just free this guy now, so at least you can turn it. So I have space to I be lay then. Or the one you are holding. I don't think it's this one. Whichever one, shall just do. Okay. This is supposed to be where the battery comes in. The bad battery. And then this is the indicator. This is where you feed NEPA in. Live neutral. This is where you feed the generator live neutral. This is where you tap out your load. Live neutral too. And don't forget, in AC there are no polarities. So you can be live neutral, neutral live neutral, does not matter. Sure you understand. These are the relays. There are 3 relays there, and you guys already know what those things are, but we'll explain them. This class is actually to discuss an automatic changeover switch. Something we already have here. We already have that. It's an automatic changeover switch. I mean, the first time we met and we were supposed to discuss this, I told you guys that the essence of an electronic engineer that you guys are is to be able to add personalized features to a design. Now, it does not matter how many times that design has been done. So long as you can add something that makes yours different from what's obtainable, you are actually added to the discourse. Some person can actually read your approach or what you have done and then come up with a design different from what you read to create yours. Do you understand that? So when we met at that time, we said we wanted to design an automatic changeover switch, and these are some of the things you guys requested for. You said first, you want an automatic changeover switch. You said you want a 15 kVA automatic changeover switch. That's where we started from, Abi? So we said 15 kVA. So these are all of the things we're going to discuss. So we were supposed to be a 15 kVA automatic changeover switch. If it's automatic changeover switch, it means it should be able to switch between generator and NEPA. At that point in time, of course, whether NEPA or PAC, depending on which of it you have in your area. We now went further to say, what kind of generator do we intend to use? Is it petrol generator or diesel generator? We agreed that what? Diesel generator. Okay? So it has to be a diesel generator. And the reason I ask is this. For petrol generator, for you to start it, apart from flipping the on switch or the power switch, you need to open the fuel valve, and then you need to maybe shock it, draw it, and then unshock it. Now, all of those processes require human effort. So it means you might not be able to run an automation on such kind of generator, unless you find a way to create another system that can help you shock and unshock it. Do you get the gist? Forget the fuel valve part. If the engine is off and you have a very good carburetor or whatever it is, whether it's injector or carburetor, it's not going to lose. The generator is not going to lose fuel. Do you understand it? So the fuel, closing and opening of the fuel is not really the issue. The issue is, can we start it without having to shock and unshock it? Now, for the diesel, you do not have to do that. There is the method with which you run the diesel generator is far different from the way you run the petrol generator. And that's it. Nobody should sleep. If you want to sleep, stand up, do exercise, and sit down. But if you sleep and you wake up and ask me a question, you will go back to sleep. Alright, can we continue? So we said it's a diesel generator. Now, the next thing you guys said is this. They said that apart from having a system that switches between NEPA and generator, you also want the result of the switch between NEPA and generator to go through another system that waits for you, to control. Which means, what do you call it? To make selection. No, not selection. The word is not selection. Enable or disable. you want to be able to either take NEPA generator voltage or NEPA supply. You want it passed through another device before it is fed into the house. So you say, even when the generator is available, NEPA is available, the moment this particular device is off, there will no be light in the house. But when it is on, then there will be light in the house. Was that not the request? That's part of the request. So it's not just about selecting between NEPA and generator, or generator and NEPA. It should also be that, is this man on? If this man is not on, then there aren't going to be lights here. See this man as your fuse. The fuse after generator and NEPA supply has been selected for you. So that if this man is not enabled or is not energized, there ain't going to be light in the house. That's another thing you guys requested for. I mean, so I just want to state all of that for the record. So when we now begin to do the explanation, it makes sense. Let's call this guy the enable. What do you call it? Let's call it the enable, because it can be enabled or disabled. So let's call it the enable. So apart from being a 15 kVA system to operate between generator and PACN, to operate a diesel generator, you should have an enable point or an enable disable point. Are you getting my point? So you want that. The other thing is this that you requested for that. You want the system to be able to work both in automatic and in manual mode. I mean, you ask for that mode. You say you want it to work in auto or manual. These are the two modes you select. In auto mode, these were the details. You said the moment the system comes up and there is availability of NEPA, let it switch the house automatically to what? To NEPA, which means PACN becomes what? Priority. So PACN is priority. Now, the next thing you then said, please, nobody should sleep. The next thing you then said is, when PACN is not available, let the system put on the generator itself, so long as it's in the what? Automatic mode. So it should be able to turn on or off the gen. The implication of this is this: as long as it's in the auto mode, there will always be light in the house. Because if there's NEPA, it turns off the generator and puts the load on NEPA, on PACN. When PACN is off, it automatically senses that PACN is off and then turns on the generator and then supplies light. Now, as it's prioritizing PACN, turning on and off the generator, the enable is also being set on automatically because it's in the auto mode. So the enable is what? On or off, depending on whether NEPA is available, or whether PACN is available, or generator is available. What then happens if you try to turn on the generator and the generator refuses to start? The idea is that it sends you a message. So this system also has what? A feedback mechanism. What do I call it? Feedback. A feedback mechanism. Such that the moment it cannot turn the generator, after a number of tries, I think I've given it 3 tries, but if you want us to give it 5 tries or 10 tries, you can do that. Now, so the moment it actually tries to turn on the generator a number of times and cannot, the next thing they do is send you a text message and let you know that, Ewa, I've tried my best with the generator, they don't come in. Now, the feedback mechanism that we have chosen is via SMS. Via what? SMS. So which means the system will require that there's a phone module in it. It also means that there's a SIM card with recharge voucher in it, which means over one way. It is with that, of course, text message is just phone error. Why do you say yeah? That's too much. Now, it is with that it's then going to be giving you those feedback. Apart from this, when it cannot, every time the system comes on, whether it's on NEPA or it's on generator, it gives you an information so you know what it is doing. When the enable is on, it lets you know. So this I will ask about. In summary, this is what it does in the auto mode. The only thing it can do, or the only things it does in the auto mode, is to prioritize NEPA if NEPA is available and put you on NEPA, also enabling the enable line so that there's light in the house. When PACN goes up, it turns on the generator for you and then put your on the enable and put the house back on NEPA, on generator, and then send the text message to the effect. And if it tries to turn on the generator and the generator does not come on after 3 trials, it also gives you a feedback, a SMS feedback message to let you know the generator did not come. So you know exactly what the system is doing at every point in time. Now, let's assume now that okay, it tries to on the generator does not start. What can you do? Few things. You will have to switch the system from the auto mode to what? To the manual mode. Because it is in the manual mode that you can actually issue instructions. In the auto mode, you can't issue instructions other than move from auto to manual or manual to auto. Those are the instructions you can issue it in the auto mode. If you issue it any instruction other than this instruction to switch from auto to manual in the auto mode, it's going to disregard it. It will receive it, but it's not going to process it, because I haven't received the message. The next thing it's going to do is to say, on what mode am I on? If I'm on the auto mode, then I'm not supposed to listen to you. I'm not going to take instructions from you other than what you have asked that I do. Are you following it? Hope I'm not too fast. Now, if you then send it a text message to switch the mode, which is part of what you can do in auto mode, you could also what? Switch the mode from auto to manual. These are the things you can actually do. You can switch from auto to manual. So these are the list of the things you can carry. You can carry out on the auto mode. Now, if you then need to actually send instructions, or some kind of instruction, you need to send your own kind of instruction. This is what you do. First of all, you need to switch it from the auto mode to the manual mode. It is then in the manual mode that you can do few things. What can you do in the manual mode? In the manual mode, you can also switch mode. Don't forget, in the manual mode, you can switch mode too. You can switch mode from auto to manual or manual to auto. You can do that in the manual mode. Also in the manual mode, you can turn on the generator, and then you can turn off the generator. Sorry, two things you can do in the manual mode. You can turn the generator on, you can turn the generator off. And every time you do so, it sends you an SMS to let you know, oh, this is what I'm doing, or this is what I am able to do. Does it make sense? Also in the manual mode, you can select each of the sources. You can select sources. You can say, oh, I want source from PACN, or I want source from what? Generator.
In manual mode too.
In the manual mode, yes. So, the generator can be running, there could be NEPA, and you say, no, I don't want NEPA light, I want generator light. That's you switching the sources. Source, NEPA source, generator source. So you can select source in manual mode. In auto mode, NEPA is prioritized. If NEPA is not available, generator becomes the next priority. While in generator, if NEPA comes on, it turns off the generator and does what? And go back to NEPA being the priority. Do you get it now? But in the manual mode, it doesn't select that for you. You are the one that decides which of the sources you want. Is it the PACN source or the what? Or the generator source? That becomes your responsibility. Also, in this manual mode, you can enable or disable that third guy, which is your enable disabled guy. Which means you can allow either the NEPA source or generator source to flow into the house, or you can disconnect it from the house. You don't get it. Do you understand it? There's a point. Don't forget we said there is supposed to have what? An enable at the disabled point. So we are saying that in manual mode, you can enable this point and you can disable it. When it is disabled, whether there is PACN source or generator source, it's going to be there, but it's not going to flow into the house. It is when you enable it that it flows into the house. Are you following it? Those are part of the things you can actually do in the manual mode. I told you that you can turn on generator, you can turn it off. You can select the source, whether PACN or generator. You can enable or disable the point that fits the house from either of the sources. Or you can switch from the manual mode back to auto mode. These are what you can do in the manual mode. This is what you can do in the auto mode. Does it make sense?
Yes.
How many things did you pick? You picked everything. If you pick everything, then you go outside. 5%. Does it make sense? It makes sense. So this is exactly what you want to do. Now, how do we achieve this? Is the question. So I mean, you sent me this manual. Gina, this I wanted to work. This I wanted to do. This what I wanted to do. This how I wanted to go. Now you have told me. Now how did we come about turning this into what we now have here? How did we do this? Let me show you. So first, what I will do is I'm going to first of all create a block diagram. The block diagram helps me decide what the what the system will require to be actualized. So let's start. So to create a block diagram, I know that first that I'm going to need a power supply. What kind of power supply do I require? I don't know yet. I know I'm going to require a power supply. I know that my power supply is supposed to feed my microcontroller. What kind of microcontroller will I be using? I don't know yet, too. But we'll find out as we proceed. Are you with me? Now, when I say I don't know yet, I don't mean I don't know. I mean, we are yet to find out. We'll find out, eh? That's what it means. Okay, so now, in my microcontroller. Now, I know if I don't know anything because of the feedback mechanism that we are using that has to do with SMS. I know I'm going to need a phone module. I'm going to need something that can send text messages. I'm going to need something that can actually take in phone numbers and send text messages to a specific phone number. Do you understand it? So it means at some point here, I'm going to need a phone module. What kind of phone module do I need? We discuss that as a process. So a phone module that fits the controller. Are you following me? Now, for me to be able to actually tell when there is NEPA and when there is no NEPA, or when there is generator and when there is no generator, it means I'm going to need a NEPA sensor, a generator sensor. I'm going to need something that lets me know which of them is available. Because if the system does not know which is available, then it does not know who to switch to. If NEPA has priority, it needs to know when NEPA is available. Its knowledge of NEPA availability is what lets it switch the load to NEPA. Do you get my point now? So we need two sensors. Can I continue?
Yeah.
Are we good? Yeah, so we need two sensors. So I'm going to need is a voltage sensor anyway. So it's a voltage sensor for generator. We're going to need another one. A voltage sensor for PACN. Are you with me? So that becomes, so we're going to need these two sensors. That makes sense. So I said you need a phone module, you need a voltage sensor, you need two voltage sensors anyway. One to tell when NEPA is available, one to tell when generator is available. Does it make sense?
Yes.
Have you continued?
Yeah.
Alright. So another thing that we are going to need. Look up. Now follow this. When NEPA is available, now we expect somebody to actually deliver NEPA to us. Isn't it? We expect somebody to deliver NEPA to us. So we're going to need relays to deliver NEPA to us. Whether relays or contactor, we'll find out which of it that we use. We're going to need somebody, we're going to need a device to deliver the NEPA to us. Don't forget, the power controller itself just works with 5 volts at 25 milliamp DC. So it can supply AC. So we're going to need somebody who's going to come in between the microcontroller and the NEPA that we require, that will be doing the switch in between. The easiest analogy I usually use for this is the relationship with very hot water to make a bath or gari and your hand. Now, when you put water on the fire, maybe to make, what do you call it by in English? Gari. Okay. And you're call it gari, so. Now, gari. Okay, so, how about our audience outside Nigeria? How will they understand what I just said? Now, gari and gari, okay. So, gari is the word. So, if you need to make gari, now you have this water boiling. Then you have this gari, you have sprinkled the gari into the water. Now you need to stir it, you need to turn it. You don't dip your hands, do you?
No.
Now, what you do is that you get something else. Maybe a turner. What will you call it in English now? Turning stick, I mean. Oh, God almighty. Then so you hold it on a stick, and then with the turning stick, you apply some pressure, and then you stir the gari together, get the mixture, isn't it? Now, but if you look at it, you actually the one who is applying the pressure, who is applying you are the one who is applying the force. Yes. But you have something between you and that very hot water, so it does not peel off your skin. Do you get it? So that's exactly what's going to happen here. So between the microcontroller and the AC that is available and the house you want to power, something needs to be in between it.
Oh, good.
Are you following me? Okay, so you're going to need a relay. Watch it. You are going to need generator relay. Are you with me? Yeah. To feed generator to the house. You are going to need PACN relay to feed PACN to the house. Are you with me? Yes. Then you are going to do one other relay. That's one that is used to what? To enable and disable. Do you get it? Yes. So what it means is that let me draw it this way. Can I clean?
Yes.
Okay. So it should mean that both your generator, let me put it here. Okay, this guy can come here. This guy can come here. Please hold on. Where is that bush board? Alright, so where did I stop? So I said, so see the generator relay, the PACN relay, they all have to feed this enable or this enable disable. It is from this enable disable that you can then what? Feed into the house. Are you getting me? But don't forget that in auto mode, this enable or this guy is enabled, especially in auto mode. So that whether there's NEPA or there's generator, there's light in the house. Are you with me? Depending on which of the sources are available. But the moment it comes down to manual mode, this enable disable line will then wait for you to either enable it or disable it for there to be light, whether from generator or from PAC. Is it making sense? So let me draw the arrow here. See this as coming here, this has come here, and this has come here, and this has come here. Does it make sense? Okay. What other thing is there? Now we have indicators. We also have indicators. We have power indicators. Primarily on the controller, we have just one LED indicator. The essence of the indicator is such that you know that this system is on. Are you with me? Now the other indicators you have, they are these ones. The one that lets you know either which of the sources are available, whether it's generator or NEPA, which one have you switched to, and if the enable disable line is on or off. Does it make sense? So that's basically what the block diagram for this system is. So what we'll do next is now we'll now begin to now break down this block diagram into each of its respective block. Does it make sense? So if you are writing, write this, or you draw it, or you snap it, whichever. But that's the block diagram for the system. Yes, a question.
Don't care about the auto.
Yes, the auto and manual.
Last one here, we talked about it switching
between auto and manual. And I said in manual, it also switch between auto and manual.
Okay, that's okay.
When the manual.
When I was saying you were sleeping, I was thinking. So you should not sleep. So if when I was saying you were sleeping, then don't ask a question.
No, I don't go back.
Now, because if you don't have this feature both on the auto mode and the manual mode, then there's a problem. So if it's in manual, it can't come out. If it's in auto, it also cannot come out. Now, please listen to this one. It does not mean that the system is not going to receive any of these instructions, irrespective of the mode. Okay. The only issue is that it's not going to actually
load.
Not load. It's not going to act on it if the instruction is coming in a mode that is not supposed to actually respond to. For instance, if you are in auto mode, you're not telling it to switch source. It's not going to answer you. If you're in auto mode, you're not saying switch turn off generator, turn off NEPA. It's not going to answer you. Or turn off the enable. You have to turn off to manual, where every given instruction, every action the system is going to carry out will be based on the instructions that you have issued it. Now let me give you a practical example of one. Please look up. Assuming you turn or you switch the mode, and now you are now in the manual mode, and then you do not turn on the generator. You just switch the load or the source from PSN to generator, and then you went inside to go and on your fan. So you are waiting for light. Next year. Right? Because you did not turn on the generator before enabling, before switching the source. Now, even if you turn on the generator and you select generator as the source, and you forget to enable this man,
You're not waiting for that again.
the generator will be running. Of course, you know the generator is running. Yeah. You have gone inside and crossed the leg on your bed waiting for light. The light isn't going to come. So understand that in manual mode, you have like 3 responsibilities.
Like you have a normal manual changeover.
Yeah, you have 3 responsibilities. You have to turn on the generator. You have to switch your source from NEPA to generator, like you will have done with your knife edge. And then, but lastly, which is what makes you different, you're not going to go to the neighbor and say, "Well, you work on the fellow." Do you get my point? Does it make sense? Can I clean that? Alright, thank you. What are you waiting for? It's on record now. Snap is you are sleeping. Please collect his phone and help him so that the event in doses of again. Now, there's something I almost omitted. When you say that the system is 15 kVA, what does it mean? Now, kVA, VA, or watts is the unit of power.
Yes.
The last time you guys were here, or the very first time we started, I gave you guys an assignment to find out the difference between volt amp and watts with power factor in respect. You guys are yet to come up with an answer. So I throw it back at you guys. I hope your supervisor asks you that question. I will be so glad. What's the question? It's on record. Thank you.
No.
Alright, so when we say 15 kV in design, what it means is that we need to find out at what current, what maximum current should flow, or at what maximum current would this system be used for. So what we are going to say is that we are going to say 15,000, which is power divided by voltage, which is roughly 240. So we pick the highest voltage. So that's going to be 1,500 divided by 24. So that is going to be looking at 60 what?
2.7.
Okay, let's say 63 amps. Are you with me? So this relays that would make the voltage available, to you must be able to stand up 63 amps. Are you with me? Now you would understand this when we get to discussing with it. That every electronic component has properties and ratings. So some devices are rated in voltage, some are rated with current, in view, some are rated with capacitance, some in frequency. So different electronic components. When it comes to relay, we find out how relays are rated. Relays that are going to be rated in their coil voltage and then the contact current. So we're going to say, so contact current and voltage also will be stated. So, but when we get to discussing, we'll discuss. So let's take the power supply first. What should the power supply entail? Now look. Now before you discuss power supply, you need to know, don't forget that this power supply will be what will supply all the voltages that's required at every point in this device or on this system. So if you are not very sure of the power requirement of every block, then you could not have come up to say you are designing a power supply for your system. Because in electronics, you go from the answer to the question, or you go from the question to the answer. I need power supply. Before you draw your power supply, you then need to know at what voltage will the phone module require supply. The phone module will require, are you with me?
Yes.
Between 3.4 to 4.3 volts DC at 2 amps. DC at 2 amps. Your generator or your voltage sensors will check the voltage sensor. The voltage sensor is actually around 3 watts. AC, both sensors are 240 volt AC at 3 watts. Interestingly, it has an output. Okay, we'll discuss that when we get to the voltage sensor. So at 3 watts, 3 watts DC now, not AC. Your LED indicator is also DC. This we should go for 3 volts. I mean, at what, say maybe 10 milliamp DC. Your microcontroller is 5 volts DC. Depending on the number of pins we are using, we'll tell the amount, the total or cumulative current that is going to be using, both as input and output. But we know that it's going to be 25 milliamp per pin. We'll discuss how many pins it's going to be needing or we'll be using for this video to tell how much current it will have used. For your generator relay, your NEPA relay and the enable relay, it uses both AC and DC. The coil is DC and it's at 12 volt DC, while the contacts are switching between 220 to 240 volt AC. So we'll discuss that. Are you there? Are you following me? Now, we haven't been told these details. I haven't been given these details. The next thing is to now decide what your power supply is going to look like. But first, let's begin with what the power supply is going to be for the microcontroller itself. Then we'll now see how every other one come to play. To discuss your power supply should look to us. Please look up. Why important? We are going to have, we said the system is going to be powered by battery. Don't forget, your DC generator is going to have a battery. The DC generator, of course, has a mechanism with which the battery is charged. So if you source voltage, of course, 12 volts, from that generator, your system is going to be on. Are you with me? And of course, it's not going to be a load. It's seriously on the battery enough to kill the battery. Are you following me? Okay. So battery must come here through, or the battery from the generator is going to come here. Now, so you expect that. Please look up. This is very key. You expect that you have a battery. Your battery is going to have positive terminal and negative terminal. The battery voltage is going to go through a switch. Are you following me? Now, the output of that switch, or after that switch, there's a capacitor here, a filtering capacitor. Before this voltage goes into a voltage regulator, a fixed voltage regulator is 7805. Now, the output of the voltage regulator is then filtered again. Are you following me? Do you understand what the voltage regulator is doing? Now, don't forget I said I'm drawing the power supply specifically for the microcontroller. The microcontroller requires 5 volts. What you have here from the battery is going to be 12 volt DC. Now, you can't feed that 12 volt DC directly into the controller. So what we have done is that we have brought in a transistor called voltage regulator that helps us absorb that 12 volts and drops it to what? 5 volts. To 5 volts for us. Are you with me? So it's going to drop it at 5 volts. We're going to have 5 volts here, but at 1 amp. So the good part of this voltage regulator, few things about this voltage regulator you should know, which is very, very wonderful, is that irrespective of the fluctuation on the input, the output of the voltage regulator remains fixed. So long as the input voltage does not go below its rated output voltage, you continue to get what? 5 volts here. This 78 is the part number that lets you know that it's a positive voltage regulator. Are you following me? Why the 05 here is output rate. Do you get it? So when you see 78, you know it's a positive voltage regulator, a fixed voltage regulator. The 05 lets you know that that's what is output voltage rating. Does it make sense? Does it make sense? Alright, thank you. So it's 5 volts. You get 5 volts here. Another good thing that this voltage regulator does for you is that it has what we call this, it has this timer shutdown. The timer shutdown. The idea is that the moment you begin to use it and it begins to get too hot, it can actually just shut down. So instead of getting damaged, it does what? It shuts down. It also has an overload protection, which means that if you bring in a load at the output that is requesting for more than the 1 amp that it can give, or say more than the 1.5 amps that some materials it can give or it can deliver, it will just what? Shut down instead of what? Getting damaged. Do you get it? So I told you before that it offers you some very good benefits. Part of those benefits is that you have a regulated output voltage that does not change at 1 amp, typical, and then it has timer shutdown and what? Overload protection. Chris, are you here?
I'm here.
Good. Can I continue? Can I continue? Now, how then do you expect your phone module to get voltage? Please look at this very, very crisply. Now, you expect that your voltage regulator should supply to you 5 volts. But of course, voltage regulator is not going to supply you 5 volts. It supply maybe around 4.9 volts. Of course, the system can still work with 4.9 volts, even 4.7 point something volts will do. What I will do, or what we did in this design is this. Look up, that from this 5 volts, don't forget your 4.9 volts is here. We send 4.9 volts through a diode. This diode is your 1N41007. 1N4007. It's a rectifying diode. Are you with me? That has a potential of 0.6 because it is made from what? Silicon. What it means is that when 4.9 volts flows through the anode to the cathode of this diode, we are going to find there is going to be 4.9 minus what? 0.6. What do you have left? 4.3. Does it make sense?
Yeah.
That makes room for the what? For between the 3.3 and the 4.3 that this man requires, that the 4 module requires. But we didn't just stop here. Because at this point, 1N4007 will not allow more than 1 amp to pass through it by rating. Why the voltage regulator itself is not going to allow more than 1 amp to flow through, which will not be enough because this 4 module requires what? 2 amp. What we've now done is that we now brought in another transistor called the TIP41 for current amplifier. Does it make sense? Let's see how that goes. Hope I'm not too fast. Of course, I am. And it's good. Are you ready? Yeah. So what happens is that I'm going to bring this to the base of another transistor. This is the collector, this is the emitter. The collector then flows back, please, to the source, and then so that your collector and your emitter, you now have your voltage filtered across here. So at this point, what's going to happen is that this transistor, this TIP41C, has as a current amplifier. I'm not going to dive so much into how that amplification is done, not now. Just understand that this transistor has as a current amplifier that helps amplify the 4.3 volt that is getting here. So that at your output, you now have what? 4.3 volts DC at the current allowable by this transistor, many times higher than what? 5 amps, sometimes as high as what? 10 amps, depending on the choice of transistor. Again, for us to be able to determine at what current transistor is giving this, we need to now begin to discuss the HFE of this transistor and how gain is calculated. So I will save you that stress. Are you following me? But understand that there's a transistor here, there's a transistor in TIP41C to help amplify the current and then keep the voltage constant so that the output are getting your 4.3 volt DC at more than the 1 amp that the voltage regulator can give and that the what this rectifying diode can offer. Does it make sense? Does it make sense? Such that your 4 module is connected in and every other device that requires 5 volts source the 5 volts from this port. Does it make sense? So 5 volts is gotten here at 1 amp, your 4.3 volts is gotten here at more than what? 1 amp. And this is where your 4 module gets its voltage supply. Does it make sense? Does it make sense? So this is what your power supply looks like. I give you a few minutes to write something. Alright? You don't even need to write. It's on record. So you have it. Can I do it? Thank you. What did you say? How many things did you pick?
I didn't pick.
Okay, last. You. Yes, sir. How many things did you pick? How much? Can we continue? Alright. Okay, so that's about the power supply. So I'm going to clear this now. And I'll tell you how to discuss the power supply. Now, let me tell you about the voltage sense very quickly. How were we able to design a voltage sensor? Look up, please. What we did with this, usually, don't forget that the voltage that generator uses or that it will supply or that the NEPA will give to us are both AC. Are you with me? Now, you can't send the AC directly into the microcontroller and to tell when NEPA is available. You need to convert that AC to DC. So what you would have done, or we would have done already, is this. Let's look at it. We will have taken that AC that is coming into a transformer. Don't forget the voltage is 220 volts to 240 volts from NEPA or from generator. we're going to take it into a main step down transformer. A transformer that can step it down to what? To 12 volt AC for us. That voltage is now going to go into a bridge rectifier. 4 diodes, 4 rectifying diodes will make a bridge rectifier such that one goes in, the other goes in. You now have your negative output here and your positive output here. Now this output is also 12 volts. Of course, it's going to be less than 12 volts because 2 of the diode are going to clip on the positive range, 2 are going to clip on the negative range. Stand up, sir. Stand up. I want you to stand up and hand. Thank you. Now 2 will clip in the positive, 2 will clip in the negative. Now if they are both 0.6, 0.6, it means 1.2 will be taken from the 12 that is coming from here. If you take 1.2 from here at 12, 1 is 11, 2 or the 2 is going to be what? 10.8 volts. So you should be expecting around 10.8 volts here. Are you following me? And that 10.8 volts cannot be sent into your controller. So what we'll do is that we're going to send this voltage into a 7805 again.
We're talking about the voltage
Sense, yes. A transformer, step down transformer to 12 volt AC. The AC is taken to a bridge rectifier and then it rectifies to DC. Even though it's DC with impurities or ripple, you can have a capacitor to help you filter part of the ripple, some of the ripple, before it's not sent into a voltage regulator. That's what the voltage regulator send it to 5 volt. But we can't actually just send a 5 volt directly to the controller itself. Are you following me? So what we now did is this. Please look up. Now of course it's DC at this point. It's DC. So what we now did was, at the output, we have a resistor to a light emitting diode to ground. That's why you have an indicator on board to let you know that, oh, there is either NEPA light, if it is NEPA you are feeding there, or the generator light if you are feeding the generator. Are you with me? So there is a 390 ohms down here, and then you have another resistor which is a 4.7k before this is now being sent into your what? Into your PIC. At the output of that PIC, from here, there is a 10k resistor to ground. Does it make sense? So please look at it. So whether it's NEPA voltage, whether it's NEPA voltage from NEPA or from generator, it goes into a main step down transformer. The main step down transformer drops it to what? To 12 volt AC. That AC is sent to a bridge rectifier to convert it to DC. The DC is filtered and then sent to a voltage regulator at 5 volt. The output of that voltage regulator through a 390 ohm resistor to LED, so that when there's light here, this light emitting diode comes on. When there's no light here, this light emitting diode goes on. Before it goes through a 4.7k resistor and then a 10k to ground before it goes into the PIC. Does it make sense? It makes sense? You get it? So you are going to need 2 of these. Are you following it? So one is going to ask for NEPA, the other is going to ask for what? Generator. But let me say this. In the process of designing the system, we did not use transformer. What we did is that we got a solid state transformer or a voltage module that already help us. The voltage module already has all of these inside. Are you following me? So what we simply did was we fed AC into it. It has an AC point. Are you with me? And it has a DC positive point and a DC negative point. So we fed. Are you with me? We fed the signal here, whether from generator or from NEPA. Yeah. While the module converted it so that at this point we have what? Our 12 volt DC. It's a voltage module. This is the module. This module. Does it make sense? So this is the module. So that when either NEPA or generator comes in, we have 2 of it. So it goes into this module. From this module is where you now have what? From the output of the module is where you have this capacitor. Are you following it? After this capacitor, it went into a voltage regulator, which is the voltage regulator that you now have here. Now the output of that voltage regulator is filtered. I will not to mention. The output of that voltage regulator is filtered before it is now sent into a resistor to an indicator, and then through a 4.7K and a 10K before it went into the PIC. So at the end of the day, every time voltage is available here, the PIC is not seeing 5 volts, the PIC is seeing around 3.3 volts DC. Does it make sense? So every time signal is here, it's seeing between what? 3.3 volts or less. Does it make sense? So you have two of this. This voltage module already has helped you replace what the mains transformer and the bridge rectifier would have done for you. Does it make sense? So that you don't get to your board and it's asking when the transformer what? They are not transformer, it's just a solid state transformer with a bridge rectifier in it. Does it make sense? So this is it. Alright, can we continue? So that is that about the voltage sense. So you have two of that. One to accommodate NEPA input, the other to accommodate generator input. Can we continue? So this is off it. Can I clean?
No.
Alright. Can we continue? Alright. Now, let me tell you something quickly about the phone module or the wireless transceiver that we are using, because it sends to us and we receive from us, so it's a transceiver. When you get the one we're actually using here, it is 800L. It has few pins. It has the VCC, it has the power pin, let me call it the VCC. It has the VSS. It has the transmits, and then it has the receive pin. So please look up. This VCC is where your between 3.4 to 4.3 volts at 2 amps goes to. Remember that power supply we did? So this is where it comes to. Where the VSS goes to the ground or the negative of your supply. Are you following me? Now, while it's on transmit, now this is your PIC, this is the TX. Okay. Call it TX and call the array. Please look up. So what happened is that, are you there? The transmit of the microcontroller will go to the receive of this one. Are you there? Why the receive of this one go to the transmit of this one? Does it make sense? So that's good. That's how they go. You see it? Transmit to receive, transmit to the receive of this. You get it? So this is the arrow. This is transmitting to this. While this is transmitting to this. So at a point, the microcontroller transmits to it. At another point, it also what? Transmits back to the microcontroller. It receives and then transmits back to the controller. So this is how they are connected. But understand that both this man and this man, don't forget this is your microcontroller. This is your microcontroller also has VSS pin. Must also be connected to what? To the negative of the supply for the transmission to be complete. Does it make sense? It makes sense? Can I continue? Alright. So that's how it's connected. So that takes this one out. Now, for the light indicator, how did we get the indicator? From your microcontroller, your MCU, you have a resistor. The resistor then comes into the light emitting diode. Don't forget this is your anode and this is your cathode. This is your 330 ohms. Does it make sense? Yes, so from a particular pin on the microcontroller through a resistor, the light emitting diode is sourced. So that the moment you say, oh, on that point, the light emitting diode just comes on. When you say hold that point, the point just go off. Now don't forget, we already said that the C module is attached to a pin on the controller. We've not decided or we've not told ourselves what pin that is. We're going to discuss the pin. We also said that the indicator, the light indicator is also connected to a pin on the mouse controller. We'll also see what that pin is as we proceed. Does it make sense? Sure makes sense. So that takes this out and that takes this out. Yes.
Why is it that it's 330 ohm resistor you use for delay?
Okay, I'll tell you. The reason I use actually I could have used between 330 to 470 or even more. I'll tell you why. The mouse controller will only give you 5 volts at 25 milliamp per pin. Are you following? I've explained this to you guys before. The LED, on the other hand, can work with between 3 volts at say 40 milliamp. Now, if requested for 40 milliamp, this guy cannot give 40 milliamp, can only give 25 milliamp. Now, if requested for 3 volts, this guy can supply 5 volts. We don't want them damaged. So what we have done is that we have created a resistor before it connects to it. How did we calculate the value of this resistor? Ohm's law says V is equal to what? IR. So we are calculating for R. So our R is going to be what? V all over R. And that V is going to be the 5 that this man is supplying minus the 3 that this man is. So we need this guy to help us keep what? 2 volts. So minus 3 all over the current we want to flow. This guy can give 25, this guy requires 40. What if we allow 10 to flow through? What if we even allow 6 to flow through? Or 7? Are you with me? 7 milliamp. So I can say 10 times, I can say 7 times 7 power minus 3. So that's going to be 2 divided by what? 7 times 10 power minus 3. What will that give? Who is going to help me? David! Help me. 2 divided by 7 milliamp.
That is 285.7.
Are you sure? Is it 3 we give to this one or 2? One. We give 2 to this one.
It's 3 we give to it.
Yes, because it's going to be 2. I'm showing you the 3. Keep 3 here, put 2 here. So it's going to be 3. Yeah, what would that give?
That's 428.6.
Thank you very much. 4.
428.57.
Say 428 ohms. You get it? Now if you use 10 milliamp, you'll be looking at, or say maybe 9 milliamp, you'll be looking at around 330 to around 470. Does it make sense? So that's how we calculate for the value of this volt, of this hour. Should it make sense? Can I continue? Can I clean now? Can I clean? Thank you very, very much. Okay. So let's quickly discuss on the relays, because this is a relay. Now, usually when I'm giving a system like this to design, what I do is that I look at the current that is supposed to flow, the current that is required in the house, to determine whether I should use a relay or a contactor. Now, from experience, I know that I can get to the market and find 30 amps relay. So I could have used the 30 amps if the project was around maybe 6.7 kV. I would use a 30 amps relay. Are you following me? I know that there's 40 amps relay, and there's 80 amps relay, there's 60 amps relay, and there's 120 amps relay. Now when I went to the market, I got a 120 amps relay. Your system requires what? 60 something amps. So you have been offered what? A 120 amps relay. This is a 120 amps relay. So I got to the market, I found a 120 amps relay. So then I decided to use a 120 amps relay for it. Which means even if you source more than 63 amps from it, it's still going to work. Standard. You source 100 amps, it's still going to work. Standard. At 120 amps, it's going to be what? 120 by what? 240 volts. What will that give you? That's what 28800 That's what 28 kVA system, isn't it? As against a 15 kVA system that you requested.
Maybe 28 kVA.
Are you guessing it? So you requested for a 15 kVA system. You have what? A 28 kVA system. Does it make sense? I thought you guys would just go out and buy me.
There was the cloud. Now let me say cloud. Don't clap. God is to the go right there.
Not this week. This week is for pizza. Pizza. You know where it is. Alright. So, but let me discuss with you what a relay is. And I'm going to be a bit slow at this point. Because if you understand how the relay works, then you understand what we have done and why we did what we have done. This is how a relay is. Now, I'm not referring to the relay here. I'm referring to how a relay is. Now, when you go to the market and you pick up a relay, and this is very important. So if you want to sleep, don't sleep again. After now, you can then go and sleep. Because we cannot explain this part, then this project cannot be actualized. When you go to the market and say you want to buy a relay or you pick up a relay has what we call coil and contact. Now, a relay is an electromagnetic switch, such that when voltage is applied on the coil, the contact connects. I will explain. A relay is going to have two coils. Call the coil C1, C2. This is where voltage is applied. So we have something like this. C1, C2. Now the relay now has what we call contact. One of the contacts is the one we call the normally closed contact. You have the normally open contact. And then you have the common. Some people call it common, some people call it wiper. This is the normally closed contact. This one is the normally open contact, and this is the common on the wiper. Now please look at
those terminal.
I said this is C1, C2. This is a coil. Coil. I've not mentioned about contact. I said coil. Now, you have this. Now this guy is the wiper or the common. Now we now have another one here. Now see this as the normally open contact. See this as the normally closed contact. And see this as your wiper. Now this is what happens. Now if you look at your vehicle, your car, you sit in front of the car, the wiper is always at a particular rest position. Which means that is normally close contact. It's making a close contact when it is off. When the driver or whoever is seated in front or who has access to controls it, what it does is that it flips to the other side, which is the normally open contact, before it then returns to his rest point. So the wiper's rest point at default, when this contact is not energized, is the normally closed contact. That's why they call it normally closed contact. Which means if you get a continuity buzzer, you put on the wiper to the normally closed to any of those contacts, the one that buzzes when the coil of the relay is not energized lets you know that is his wiper to his normally closed contact. Now the moment you put voltage on this coil, this wiper switches from this place and then lashes itself in. The moment the voltage is, there's no coil voltage again, it switches from here and then switches back. Do you get it? So you see the wiper keeps going up and down, up and down. I'll discuss how we now took advantage of it. But to understand that it is the voltage at the coil that determines when the wiper is what? It's like the way I was watching a video, sorry, a while ago. Your teacher say do like this, and it takes this bull out, very big cane, and gives you at the back. I mean the first one to run, you know, that's what happens. You get it? So that cane, the pain or that beat, that's your coil voltage. Your voltage was applied. Okay. That's the charge, that's the activator. And then you start it. You get it? Does it make sense? Okay. So now, but when you go to the market, you need to be careful of the kind of relay you get, because the coils are rated differently. There are some you go to the market, you are going to say, oh, they are going to tell you this particular coil is 12 volts DC. Some they will tell you it is 24 volts DC. While some they will tell you it's 220 to 240 volts AC. Now, if they tell you that it's an AC coil, it means it is 220 volts that you can use to do what? Energize this coil. If they tell you that it is 24 volt DC, it's 24 volt DC that can energize this coil. And if they tell you it is 12 volt, it means it is 12 volt that can energize this coil. Because from my power supply, I'm not going to have more than 12 volt DC there. I've decided to go to America to go and buy what? A 12 volt coil relay. That's why I went for a 12 volt coil relay. Now, it then doesn't matter what the contact voltage is. Don't forget, the contact voltage is different from the what? From the coil voltage. Now, after you have satisfied the coil voltage, whether it is 12 volt AC, 12 volt DC, 24 volt DC, or 220 volt AC, after you have decided it, you now have to say, what is the coil voltage? There are some that are 10 volt coil. Even I forgot to tell you, there is also 5 volt coil. 5 volt DC coil. Are you with me? Now, there's some 5 volt DC coil that is 10 amps. The contact is 10 amps. There's some 12 volt DC coil that the contact is 10 amps. Are you following me? So separate the contact from the coil. The coil rating will be the voltage you use to energize the coil. The contact is different. The contact is just there to switch things. Are you with me? And many times we are not very careful. We are not really concerned about the coil, about the contact voltage. We are more concerned about the contact current. For instance, if it's like if I need to pass something to you, hey, take very good. When you pick up a bottle, maybe a Coca-Cola bottle, when you put it in your mouth, the rate of flow will be based on the width of that bottle. It's not how much you can swallow. It's on the rate, the diameter of the cup. Are you with me? Now, if you now bring a bigger bottle, if you do like this, you realize that you almost get choked. Because the rate of flow and the amount that is coming at the time becomes so much, you don't even have time to swallow and take in another one, so it begins to pour. Do you get it? Now, imagine you now put a straw in the bottle. The rate at which you sip it will be based on the what? On the width of the straw. Are you following me? What the straw can carry or can allow is what will be delivered to you per time. That is the same with the contact of the relay. If the contact cannot stand the current you want to receive, when that load requests for that signal at that current, the contact fries off. Are you with me? Now, when in discussing contacts, I told you there is 10 amps contact, there is 30 amps contact, there is 40 amps contact, there is 60, there is 80, there is 100, there is 120. I got you a 120 amps rated contact. Are you following me? Such that irrespective of what you put in, it should be able to allow that signal at a maximum of 120 amps. The moment you exceed the 120 amps, then the contact does what? It fries up. Are you following me? And you can't even exceed it. You following? Can we continue? So this is actually how the relay is used. Now, but please look up. Or this is me explaining the relay. Let me now show you how the relay was used. Are you with me? How it was used. Not in total regards to this, but how it will be used to actually supply AC. Please look up. Are you there? Now, assume again that this is a relay, this is a coil, this is the wiper. This is, so you know that this is the normally closed contact, isn't it? This is the normally open contact, and this is your common. You be? Alright, let's look. Assume that I have a bulb. Please look at this. This is a bulb. Then, please look up. I have my source. My AC source. Here is live. Here is neutral. The bulb is AC powered, so the source requires live and requires neutral. Please tell me, if I connect the live to this place and I connect the neutral to this source, what happens to this bulb? It comes on, isn't it? Yes. Now, if I need to off the bulb, all I need to do is to just disconnect one of the points. I don't need to disconnect both points. Just one. Now, if I had a switch here, when this switch is open, this means neutral is already given. It is waiting for live to be given. The moment I close this switch, this bulb comes on, isn't it? The moment I flip this switch open, what happens? The bulb goes off again. Please, are you following my analogy? So what I'm doing is that I'm using live to switch the bulb on or to switch it off with the help of this word, mechanical switch. The good thing about the switch is that I can also switch neutral. I can place the switch here so that when the switch is open, live is already available, neutral is what is missing. So that the moment I close this switch, neutral is given, the bulb comes on. When I open the switch again, then the bulb goes on. Does it make sense? Do you understand what I did? One of the line is given, the other line is who I'm actually playing gamble with. Do you get it? Now please look at it. If I was to now replace this switch with a relay, what the relay is essentially there to do? How will he have done it? Now, somebody will have asked. Don't worry. We'll get it. Okay, please look up. Now you see this relay. What I will now do is this. Please look up. I will take the neutral. I will connect the neutral to the bulb. So what's the bulb waiting for? Live. I will now take this live. Please look up to the wiper. I will now take the normally open contact and now connect to the live. Are you following it? Look at it very well. So this is what happens. The moment the coil of this relay is not energized, the common remains on the what? Normally closed contact. Why your bulb is live tag is connected to the normally closed contact, and then its neutral is connected to the neutral source.
The normally open contact.
Oh, so normally open contact of the relay. Thank you very much. And then the neutral of the bulb is connected to the source of neutral. So neutral is given. If I need this bulb to come on, what do? I just simply need to energize the coil of this relay so that the common can switch from this place and then do what? Switch on this and contact it. So that the new light that you already have from the source can flow from the common into the normally open contact or through the normally contact into the light part, and then the bulb comes on. What did you say? Does this make sense? Now, if I need to turn on the bulb, what do? I just simply remove the coil voltage of this relay. By removing the coil voltage of this relay, what happens? The wiper moves again from the normally open contact and stays on the normally contact that is not connected to anybody. And then the bulb goes. This is how you will have used small relay like this to supply a signal like this. Now please look up. This is where the current rating is now important. If you pick up a bulb in your house, say maybe they say the bulb is 100 watts. Please look up very well. If they told you that this bulb is 100 watts, and the voltage that is coming on with is between 220 to 240 volts, power or current will be what? Power divided by what? Voltage. So you are going to say 100 divided by what? 240, which is minus. So we are looking at what? 10 divided by 24, which will give us what? 10 divided by 24 is what? 0.42 amps. Now, if this relay was rated any coil voltage, but the coil voltage, or when the current they wrote on the body, they wrote 0.1 amp. The moment you turn on this bulb, and this bulb, and I mean, the moment you energize the coil of this relay, and this wiper moves from here to this point, what happens is this bulb is expressing what? 0.4 amps. But they told that the contact of this relay can only stand what? 0.1 amp. What will happen is that this contact through which this signal is supplied, through which neutral is supplied, through which light is supplied, will burn off. It's like you using a flex to draw voltage from one point to the other point. It will melt. The moment the current that is flowing through the flex becomes too much. So the contact of this relay, whether it is going to be the normally open contact or the wiper, will burn off. Because you are asking for it to pass through it what it cannot pass. It's like when you have a bridge that is meant for just bicycles. A trailer, one now to go on it. Do you get the point? That that's what happens. Now, because the relay that we have used in your own project is 120 amps, it means that it will be able to stand even a load of what? 28 kV. Do you get it now? It's 28, it's 28, it's 28 or 24? 28.8. Does it make sense? Do you get it? Now, the question you are going to ask is, how then do you control the coil of the relay? Very simple. That's also very simple. Don't forget that the coil of the relay, or the voltage applied on the coil of the relay, comes from the microcontroller. But please look at how that happens. Now, the coil of the relay, we said that it is DC, it is 12 volts, yes. Which means it requires positive supply here and negative supply here. And we said that, oh, the coil is 12 volts. Now, if I have a supply, please look up, that supply is different from this supply now. Yeah. If I now have a supply, a DC supply, or a DC source, that can supply me 12 volts, don't forget this is supplying 220 to 240 volts AC, this is supplying 12 volts DC, it has positive, here we are talking live and neutral, here we are talking positive and negative. And look at what I'm going to do. I am going to make this positive available to this man. I will now be using my microcontroller to switch what? Negative. How will I switch negative? That is where the knowledge of transistor as a switch comes in play. How is that done? You find a transistor looking thus. You have the base, you have the collector, and then you have the emitter. This is E. This is C. This will be an NPN transistor. Now please look up. Now, when the base of this transistor is not biased, of course, you need around 0.7 volt to bias the base of the transistor, or more, a bit more. Now, that's bias add, you need about 0.7. Now, when the base of the transistor is not biased, which means there's no voltage at the base of the transistor, your collector and your emitter they have the very high resistance in between them, like potential A. It has very high potential, very high resistance across it. So it's not connected. Are you with me? It's isolated. The collector is isolated from the emitter. That is when the base is not biased. But when the base is biased, that resistance wall collapses. such that your collector and your emitter has very, very low resistance. When you put your meter across them, it's going to boost because it's very low resistance. Almost as though there's a wire, there's a straight wire connecting them. Are you following it? Now, your microcontroller can actually give 5 volts. So if I bring, please look up. If I bring my controller here at 5 volt DC and I have a resistor at 10 kilo ohms to the base of the transistor, call that transistor BC547. Are you following it? Now, if I take the collector and I connect the collector to this point, then I connect the emitter to the negative of my supply, which is ground. Are you with me? Now look at it. The relay already has positive. It is waiting for what? Negative. The negative from my supply are taken to the what?
To the ground.
Not to ground. To the emitter of the transistor. To the emitter of the transistor. Are you following it? Why are not to the collector to the negative side of the relay? Now, the moment the controller biases the base of this guy, what happens? Here and here read like an ordinary wire, such that the negative of the relay is taken through the collector to the emitter, to the what? To the negative of the supply, and then the relay is energized. And then you can switch. Then the moment I want to off the relay, or I want to off this bulb, not the relay, the bulb. To off this bulb, I need to actually switch the wiper back to the normally close contact. To switch to the normally close contact, this relay needs to lose coil voltage. For it to lose coil voltage, all I simply need to do is to withdraw my 5 volt here to the 0 volt. And what happens? The potential here increases. So here and here acts as though they are what? They are separated. Such that the negative of the supply is separated, that is on the emitter is separated from the collector that is carrying what? The negative side of the relay coil. And then it goes on. So this is how you are going to use a very small voltage. Small voltage as low as 0.7 volts to switch a very big relay of around what? 120 amps at 220 volts AC. That is the relationship between the hot water, the homologo, and you. Do you get it? Does it make sense? Sure, make sense. This is how the relay works. Except that in the case of your own project, the relay we are using has two of all of these things. It has one coil, but it has 2 wiper, 2 normally closed contacts, and 2 normally open contacts. The one we used.
It has a coil.
It has 1 coil, 2 common, 2 normally closed contacts, 2 normally open contacts. How we took advantage of that is the next explanation. Do you understand it? What did you say? Do you understand? Can I clean? Can I continue? How many hours have I spent now? 1 hour 25 minutes. I thought I was going to run all of this up in 1 hour. Maybe if I talk more, the pizza money comes just to increase. And you that is laughing at the back. Hope you are beginning to, you are keeping your money. Yes. We are stand up. We are stand up. I'm taking extra. I have told you that my responsibility is to teach you principle. Yours is to apply. What I'm doing, I'm applying it. So you do not pay for this. Okay. Now let me tell you about the relay that you have. Now look at the relay. The relay looks like this, something like this. Please look at it very well. It has a point here and a point here. Call that point C1 and C2. So this is your coil. Are you with me? Yeah. It now has common. It now has two common. Common one, common two. Are you following me? It now has normally close contact one, normally close contact two. Then here, normally open contact one, normally open contact two. Are you following? Now, this and there, they are not connected. It's like having two in one. Yes. So this is what happens. Whenever you apply positive 12 volts to the first coil and you put the ground of your supply, what happens is that your wiper or your common, oh, this is coil now because it's red. You following? Yeah. So, the moment you apply coil voltage to the coil 1 and coil 2, what happens is that your common that was formerly connected to the normally close contact of 1 leaves here and will be connected to normally open contact. This one too, the common that was formerly connected to this place, to the normally close contact 2, begin to make connection with normally close contact 1. Are you saying? So every time you apply coil voltage, this side connects, this side connects. So what we have done, or what we did is this. We sent in your NEPA live on one, your NEPA neutral on the other hand. So one like this is for NEPA. We now have another one that's for generator, live and neutral also. So that the moment you on this particular relay, your NEPA live and neutral is available. Let me draw it so that you can understand what I'm doing. Do you understand what I just did? That's what I just did. Let me draw it.
Voltage supply become activated, both the two sides normally close contact and it comes to the normal way.
Yes, immediately. So you now have something like this. See this for PSN. See this for generator. The third one. See for that way. So you have live going here, neutral going here, live going here, neutral. So this is live, this is for what? PACN, this is for what? Generator. Now don't forget, the output of this will connect to this one. Are you following? So that this will connect to this. Why this connects it? This connects it. Now pick up your output. So this is what happens. Whenever NEPA is available, are you with me? Don't forget this side is the input, this side is the output, this is now input, here is now output. Now please look at this. Don't forget the drawing that I showed you of how to run a ball. Do you forget? Don't forget it. Please look up. If you place, please look at this. If you place NEPA live, are you with me? On your common and NEPA neutral on the common, and you take the output from your normally open contact here. Are you with me? When the relay coil is not energized, what happens? What is on the common is also latched on the what? Normally closed contact, not on the normally open contact. But the moment the relay is energized, the relay, the wiper that has your live and neutral moves from normally closed contact of both and is connected to the normally open contact of both. That normally open contact of both is this point. This is the normally open contact 1. This is normally open contact 2. Normally open contact 1. Normally open contact 2. This is now your wiper 1, wiper 2. Normally open contact 1. Normally open contact 2. Do you get it? Why this is now your wiper 1, wiper 2, wiper 1, wiper 2, or comma 1, comma 2. Does it make sense? Please, do you understand it? Yes. Please follow it. Don't forget, NEPA is available on the common. But the common is latched on what? Normally close contact, which is live and neutral is here, so long as this relay is not energized. But that is not where you source your wire from. You source your output wire from the what? Normally open contact of each. What it means that if you put a bulb across here and you fed live and neutral to the common, and this coil is not energized, the bulb is going to be off. The moment the coil is energized with 12 volts, the live and neutral that is here is impressed on normally open contact 1 and normally open contact 2, and that bulb comes on. So this is how it's connected. So this is the issue. Assume that NEPA is available here. NEPA is on your what? Wiper 1, wiper 2. Generator is also available. Generator is on wiper 1 and wiper 2. But you are going to choose to pick what? Normally open contact 1, normally open contact, normally open contact 1, normally open contact 2. It is the one that you now energize. The coil that you energize is the one that will switch. Are you following me? So don't forget, there's coil 1, coil 2, coil 1, coil 2, coil 1, coil 2. Do you get it? What happens when you energize both coils? What will happen? I need you to tell me what happens if you run this coil 1 and coil 2 together.
You are sending two sources at the same time to the output.
To the output. Now, you are not actually sending two sources to the output.
Yes. You are sending it to normally.
No. You are combining them. They are connected together.
Okay.
So your NEPA voltage and generator voltage will jam. Because it's not a problem. The problem is make sure only one is on per time. That when this is on, this is off. And when this is off, this could be on. Because if this is on and this is off, this is what happens. The voltage, the NEPA voltage that your supply is available here, but it's also seen here and seen here. But because there's an isolation between the normally open contact and the wiper, they don't jump. Are you getting me? Are you getting it? But the moment you go and on this one, when this one is on, what happens is that NEPA that is here goes in here and enters into generator that is here and here. Of course, NEPA is going to have more magnitude than generator. So NEPA will push back into the generator and then it's going to bump your generator. The APR will go off, another part of the generator will go off. And then you now go and buy another generator for another changeover switch of how much? Yeah, you don't have to get it, you were sleeping. Don't ask question. He was sleeping. Do you want to do a replay so you can see what he was doing when I was explaining? Come and do a replay.
No.
He was sleeping. Okay, what don't you understand?
What are you talking about?
This point. I just told you how the coil of the relay works.
This piece of the combination, that's what I'm saying.
Okay, I'm saying, look at it. Look at it. I took the normally open contact of this one. I connected it to the normally open contact of this one too, so they are connected. I took the normally open contact of this one and I took it to this one, so they are connected. We now fed both into this one, and don't forget this is the enable. If you don't enable this one, there's not going to be output voltage there. Don't forget. The idea is that so that whether there's light on NEPA or there's on generator, it's available here. So the moment this is enabled, if generator is on, you find generator. If NEPA is on, you find it here. The only issue is that you cannot enable this coil together. If this is on, this must be off. If this is off, then this is on. Or both can be off. But not two. The both of them cannot be on at the same time. This can be on anyway. This can be on at any point in time. But these two cannot be on at the same time. Why? Please look up. Don't forget that this is for NEPA. Don't forget that this is for generator. Look at it. The generator source is in your what? Common 1, common 2. The NEPA source, NEPA source is on your what? Common 1, common 2, which is life and neutral. Your generator is on what? Wiper 1, wiper 2, which is common 1, common 2. We now took their normally open contacts. We bridge the normally open contact of the first one with the second one together. We bridge the second normally open contact together, we bridge to the other one. So this is what happens. When NEPA is on, so NEPA is available, and you energize this coil. The voltage that is on your wiper is now that was previously impressed on your normally closed contact, leaves the normally closed contact and switch to your normally open contact. So the voltage is here. So the voltage travels through here to this place. Don't forget this guy, you can see it. But this guy is not going to react because that voltage is on his own normally open contact. Why the voltage that is here? Why the coil is off is on his what? Normally closed contact. Okay. So there's no way they can jam. Even if you manually start the generator, it's not on. How can it be on? Voltage can be here, voltage can be here. As long as you don't energize them, that's the point. So when we say on, we are saying the coil. So as long as this coil is on and this coil is off, what is here, but we not jam with what is here. If this is on and this is off, whoever is here is also here. But we not jam with this because they are different contacts. One is on normally open contact, the other is on the normally closed contact. Yes, on normally open contact, the wiper signal is on the normally closed contact. So they are not going to jam. So also, the combination of this and this is also available on the what? On the wiper 1 and wiper 2 of this. And as long as you don't energize the coil, it's not going to be available on the what? Normally open contact and the normally open contact of the second one. Does it make sense? So this is how the system was arranged. Again, show them. That's why you have this. That's why you now have NEPA signal going through this place to this, generator signal going into this, and then the output is fed from here. This is the reason you have this loop here. This loop happening here and this loop happening here. This loop. That's why you have this loop going. So that when there's net voltage on this point, this man too can see it. This normally open contact can see it. But because the coil is off, it will not mix with what is in his what? With his what is in his common, which is wiper, or normally closed contact. Only jam. So your responsibility is to make sure that in switching any on, you don't switch these two on at the same time.
Automatic no takes care of that. The two cannot be on the same time.
Yes, even your manual mode takes care of it. Your manual, you only send information to you to put something on and off. It knows what you want to put on. So you say, oh, put on generator. You switch off NEPA and put on generator. the coil. NEPA can be here, generator can be on, and generator source in here. NEPA can be available and NEPA source in there. It is whose coil is on that transfer to the need. So the way it's done is, if you need to on the coil of NEPA, then you off the coil of generator. If you need to on the coil of generator, then you off the coil of NEPA. And then you can then on this coil for the enable or off the coil for the disable. Let me hear your question.
Okay, so for instance now, I'm running on NEPA supply.
Yes.
That's PHC.
So which means NEPA is available.
NEPA is available.
This coil is on, this coil is off, and this coil is on.
Yes.
Okay?
So which means I have NEPA on my.
Yes, you have NEPA, yes, at home.
And maybe the voltage of NEPA dropped.
Yes.
So now, if I want to, I'm on first I'm on manual mode.
You are manual mode. Yes.
So now I want to switch on. I want to switch on my gen.
And then let gen supply the other. It's simple. What you simply do is, first of all, on your generator. So your generator is on. So generator source is available just the way NEPA source is available here.
Okay.
But don't forget, the moment you switch to manual, what it does is that it offs all the contact of the relays, the coil of the relay. It offs this, it offs this, it offs this automatically itself. It now begins to get instruction from you. On generator, generator is started. So generator is available. Don't forget, NEPA is also available, just low. Are you with me? You now say, okay, on generator coil. So you on this coil and off this coil.
Okay, so as soon as you receive the instruction that generator coil to come on,
Yes.
it automatically turns off PCN coil.
It will not. You are the one that will tell you to turn it off.
So if what if the user is forgetting to instruct the PCN to go off first before I send the gen to
And you start the gen, but this is off, the coil is off, the generator, the voltage is just going to be there.
Yes.
As long as the coil is not on the coil, it's intelligent.
Yes, I understand. The coil of the PCN is currently on.
It's on.
It's on.
As long as this is on, this will be off. As long as this is on, this is off. It's already in its code. No two can come on at the same time. It's not your doing. Because the system is foolproof. Are you with me? No two of these can be on at the same time. You can't on both. The moment you send it an instruction to on this, it offs this. The moment you tell it to on this, it offs this. Now, it's not offing the generator on the NEPA, it's offing the coil. Thank you very much. But this is it. The moment you switch it from automatic to manual, it offs all the coils.
Okay.
All of them are off first.
Yes.
It now begin to wait for your instruction. So if you say, oh, on generator, it on generator. Generator is there. Generator supply is there. Doesn't mean that you have it at home. No. Your next responsibility is to say, oh yeah, on generator core, which is you are switching source. I want generator as a source. So you enable this, the coil of this relay, and put up the coil of this particular one. So the voltage is here. But the voltage is not yet here. The next instruction you tell it is what? Enable this guy, then that's when you receive the voltage. So it puts, that's not the question. Okay.
Let me start over again.
Okay.
We are in the manual mode.
Okay.
All the coil contact is turned off, right?
Okay, we are in manual mode.
Yes, manual mode.
Okay.
All coil contact is turned off.
Who turned it off?
I know. So
How did you turn it off?
Because you said as soon as the manual mode, all the.
Thank you.
So now there's NEPA's
Yes.
PCN available.
Yes.
So now I'm turning on the contacts for NEPA.
Calm down. NEPA is available.
Yes.
Yeah.
So now I turned on the contacts for NEPA.
You turn on the contact for NEPA. So signal is here, okay?
And now I turn on the contacts for enable, so that I can finally have NEPA in my house.
Thank you.
But now all of a sudden PCN voltage dropped.
Okay.
And I want to switch to generator.
Yes.
So now I've turned on the gen, but I'm yet to allow it flowing.
Yes.
So do I have to instruct PCN contact coil to go off first
Before
I now instruct, or immediately I tell gen contact to come on?
it offs this. But that's what I've been saying, but that's what I said.
You're saying that in automatic mode, it automatic, like both of them can't be on, which I understand.
In manual mode too, that's why I said the system is foolproof. When you say on this, it doesn't wait for you to tell it to hold this, because if this was on, when you ask it to hold this, are you not creating wahala? So the instructions are there. The only issue is that when you say on this, it offs this to on this. When you say on this, it offs this to on this. It does it automatically for you.
All of in the automatic.
But
In automatic mode, it does the same.
yes, but you are the one that tells it.
The instruction on what to do.
Then are you following me? Coupled with, you know, you can switch sources, which is what they say. NEPA is available. But while NEPA is available and you on this source is off. NEPA is now low. Of course, the voltage is in the house. You are seeing 110, 180. Say, oh no, more fairly. I want 220. Are you with me? What do you do to the system? You tell the people, I want to switch my source. It says, what source do you want to switch to? I want to switch my source to NEPA. Of course, to generator. Don't forget, in manual mode, it does not have priority. Who is the priority? You are the priority. Whatever you ask it to do or states is priority for it. So it's okay, switch to generator. The moment you tell it to switch to generator, it automatically does what? Switch off this man for you. Not switch off the generator. Not switch off NEPA. He only disconnects this coil so that it is not supplied to the house. And it's turned this one off too. You will always have to on this after an instruction to either on this or on this. You will always. Why? Because these two can be available, or either of these two can be available, and you can also disconnect this and not have the light flow to the house, which is part of the features you guys requested for. So every time you switch to manual, his first responsibility is to off all coils. I don't say it offs generator.
No.
Off the coil, generator can be running. Which means if you don't even tell it to off generator and you just switch source to NEPA, the generator will continue to run. But it's not what is supplying. Why? Because the coil of the relay that will have switched generator is off. It doesn't make sense. That's why I said the system is foolproof. Because the truth is, you can actually forget. And because you can forget, the system is not going to be stupid. Okay, so this is actually how it is. It is wired, and then now let me tell you something quickly about these indicators. Now there are 5 indicators there. So let me explain what those indicators does. There is one attached to this place. So when NEPA is available, it comes on. There's another one attached to this place. When generator is available, it comes on. There's one attached to this point too. When
It's being enabled.
when it's enabled, which is the output, it comes on. Are you with me? Now, when either of this is connected or is switched, we expect 1, 2 to be on. So which means one is should be connected to the normally open contact of this and of this. But because their normally open contact are breached, so whether you put one here on the normal open contact and put you on your normal open contact, whether it is NEPA, it will come on. The two will come on. Whether it is J, the two will come on because they are connected. So we cannot take indicator from the normally open contact. So what we did was we took the indicator from the what? Coil contact. Bros. I'm not talking about the coil contact being energized. Yeah, it's the same thing with this. Yes, sir. And what I explained now is about the same thing about the relay. I only said that it is double. That's what I said. I only said this was just has 2.
Twice the wiper.
I didn't say twice. You just have 2 wipers.
2 wipers
With 1 coil. I mean, that was the job.
So how would they be connected from the microcontroller now? Since they have,
But we have not gotten the calm down. Have we told the
I'll
mouse
say that
that?
you don't explain that. You said
If the mouth controller has not explained how this is connected, I have explained it here. I said here goes to 12 volts DC. I said here goes to the negative of your supply. Jesus Christ, why am I always using it? Shebi is there already. Shebonri. Shebonri. But then what I did, and I went further and said how it would have been done is that, which is what I did here. Transistor as a switch, which is what I do here. Please, do you want to go back to the recording? Or do you want to show it to me?
I remember what you explained generally.
Generally.
I'm asking in reference to our own blueprint. I was we applying the same thing?
Yes, we are. Can I continue that? Now please look at this. Indicator here, all AC. But we cannot use AC here. But if you put AC on normally open contact, either of the supply will hum both. So we won't even know which one was on, which one was off. So what we did is that we kept one on the contact of the first one, the second on the contact of this, so that the moment this coil is energized, that LED does what? Come on to tell you that this is the relay that is energized. The moment it is, which means and of course don't forget that no two can come on at the same time. So when this is on, of course we know that this is going to be off. When this is off or this is on, you know definitely this is going to be on. So do you get my point now?
But
so
manually, it requires the instruction of one being off before one being the other.
It's full.
Manually, now you are operating it manually.
we are not see, don't bring manual automatic. Don't worry about manual automatic. What you should be concerned is when the contact of the relay is energized, the indicator that is there comes on. When the contact of this relay is energized, the relay that is there comes on. Do you get my point? So whether both comes on or one comes on, just understand that if this comes on, understand that the contact of this relay and the coil of this relay is energized. If this comes on, the coil of the relay is energized. The day you see both come on, just take to your heels. Be running. Do you get my point? Do you understand it? Now all of these three can come on to show that NEPA source is available, general source is available, and the label is on. So there's light. But only one of these will be on. If you find the two of these on, sorry, because if you wait, the explosion can definitely. The implication is therefore this: that the lamp that is here is AC, the lamp that is here is AC, the lamp that is here is AC, but the two that is here are going to be what? DC, because they are sourced from the what? From the coil of the relay. Do you get my point now? Now, that's why you have AC, these two are DC. Even though they look alike, this is AC, this is DC, this is DC, this is AC. Does it make sense? And I continue. Alright. Now, let's now get back to our controller, and then our controller is our unifying factor. It should help us explain how every other person is. And I need to explain that quickly before this laptop dies. It dies.
How much are you using?
The
material.
the material.
Your written document there.
There's no document here. Everything I've said, please, can you stand up? Please come. Come. Everything I said today is from my head. Look at what I'm looking at. It's drawing. Yes, I was sending a drawing to you. It's not a written document. Why do you want to have a written document when there is an audio document? Can you continue? I'm just joking. There's no written document. It's in that. Okay, so let me do this with you. Are you ready? So that's the last block. The mount controller that we are using, please look on. Is a PIC 16F8768. So let me give you the pin assignment quickly. Our pin 9 and 10 has our OS1, OS2. Our pin 2, 4, and 5. So that's pin 2, 4, and 5. The pin 2 is our power LED. The pin 4 is the PACN sense. Why this is the gen sense. Your pin 17 and 18. 17 is your transmit, 18 is your receive. Your pin 12, 13, 14 has the relay. This is the PACN relay, then relay, the enable relay. You now have pin 27 and 28. Pin 27 and 28. One is, okay, this is your crank. This is your valve. Alright. So that's the pin on the back line that we used. So let me, now that I have it down, even if it goes up, I'll just continue our explanation. Please look up. The control that we are using is actually a 28 pin IC. It's a 28 pin IC. 28 pin IC means it has 28 pins. In those 28 pins, or in that 28 pin, there are some pins that have been used to carry out some very particular action. For instance, are you there? Your pin 1 is your MCLR, your pin 8 and 19 is your VSS, your pin 20 is your VDD. And let me explain. Just like any digital IC, the microcontroller requires power to come on. Everything. So your pin 20 is where your plus 5 volt supply comes to. Do you understand?
Yes.
Your pin 20, your 5 volt supply. Your pin 8 and pin 19 are what goes to the negative of the supply. That's true. So this is 1, 2, 3. Does it make sense? Now, there's another pin called pin 1. That pin is called your master clear reset. That pin goes through a resistor to your VDD. It goes through a 10 kilo resistor to your supply. Do you understand this? Look at it. Your pin 20 goes to your supply. Your pin 8 and 19 goes to the negative of your supply. While your pin 1 goes through a resistor to your supply. Does it make sense? Is it clear? So we are taking out 1, 2, 3, 4. Now there's now a pin 9 and pin 10. That pin 9 and pin 10 is where your oscillator stays in. The microcontroller has an oscillator. The oscillator is from where it generates pulse to execute its instructions. Are you following me? That pin is your pin 9 and 10. So which means, for instance, assume that this is your microcontroller, this is your pin 9 and your pin 10. You have your crystal oscillatory capacitor connected to your pin 9 and your pin 10. Are you following? So that on this end, you have a starting capacitor here, and that starting capacitor connected here, and this comes to the negative of the supply. This guy is your 4 megahertz crystal. This is your 22 picofarad. 22 picofarad capacitor. Is it clear? Crystal oscillator capacitor across pin 9 and 10. Across your pin 9, and that's why it's called oscillator 1 or oscillator 2. That's where your crystal oscillator capacitor is connected. Are you following me? The import of the crystal oscillator capacitor is that your microcontroller uses 1/4, whatever is it, to carry out its own instruction. And what you use there is 4 megahertz crystal. That's going to be 1/4 times what? 4 megahertz. We give you what? 1 megahertz. So the microcontroller uses 1 megahertz to carry out its instruction, because what we have here is a what? 4 megahertz crystal. If we have had an 8 megahertz crystal, what would the microcontroller have used? That's 2 megahertz. But that's going to be 1/4 of 8. That's 2. If this place was 16, if the microcontroller would have used what? 4 megahertz. If this place was 20, the microcontroller would have used what? 5 megahertz. Don't forget, any crystal oscillator that you put here, the controller uses what? 1/4 of it. Can I continue? So that's the implication. So look at it. This pin is gone, this pin is used, this pin is used, this pin is used, this pin, and this pin. How many pins is being used now?
6.
6 pins. So if you take 6 from the 28, how many pins is left? So you have 22 input output pins. Does it make sense? Is it clear? Can I clean? Okay. So you have 22 input output pins. Don't forget, you are taking out this, you are taking out this, you are taking out this, you are taking out this. So this is what you have left. Is it clear? Now your pin 2 is where that power LED came into. And I told you how the power LED was connected. That from that pin 2, it went through a resistor to the what? To the light emitting diode. And I said this place is what? 330 ohms. Does it make sense? Do you remember it? You remember it? That pin 2 is your RA0. What do I call it? RA0. So your 4, Emmanuel, and 5 will be what? RA what? And RA2 and RA3. If 2 is RA0, if 3 is not RA1. Well done. Your pin 17 and 18 is RC6. RC7, I'm just going to explain all of that. Why your pin 12, 13, 14, 12, 13, 14 is RC1, RC2, and RC3. Why your 27, 28 is going to be your RB6 and 7. Alright. Please look up. Can we continue? So you see that this power LED is connected through your pin 2 to what? To this place. If I need to on the power LED, because the power LED is connected on pin 2, and pin 2 is your RA0, what I would do is I'm going to say in code output underscore AI on pin underscore A0. This is how the LED comes on. Output underscore AI. If I want this LED to go off, I will just say thank you. Output underscore low on pin underscore A0. Does it make sense? Do you get it? Now, this number is the external pin number. This name are what it is called internally. Are you getting me? You know, don't forget, I didn't say I put the eye on pin 2. I said I put the eye on what? Pin underscore what? A0, because that is the name. Are you following me? That is how it came. Do you understand it? So this is how you put it on, this is how you put it off. This LED. Does it make sense? It makes sense? Can I clean? Now, I told you that your pin 4 and pin 5 are your NEPA sense and your generator sense. Don't forget the drawing of the voltage sensor. Don't forget. We said there's a module, it has AC, it has positive and negative. So our AC comes in here, whether from generator or from NEPA. Let's assume that this is from NEPA. It went in here. The output of this guy has a capacitor to filter it. It was now sent into a 78 over which is a voltage regulator. The output of the voltage regulator has another capacitor to filter it. Are you following? We now say that output now has a resistor to what? A light emitting diode. So that when there's voltage here, this indicator comes on to let us know that there's signal. This place now goes through what? The 4.7 pin to the PIC pin. Then you have a 10K to ground here. This pin is your what? Do you get it? So you now have another one of these that is feeding this place. So that is NEPA that is fed into the input of the first one. Generator is fed into the input of the second one. Does this make sense? I've drawn this before. I'm just telling you how it then connects to this place. So whenever there's NEPA, this place comes high. There's a 3.3 volts here. When there's no NEPA, this place goes to what? 0 volts. When there's generator, this place comes to the 3.3 volts. When there's no generator, it comes to 0 volts. Do you understand?
That's the generator.
That's the generator point. They're saying the same thing. Do you understand it now? So you have two of these, one connected to the power, the other connected to the generator. I've drawn this before, I just intend to draw it again. So how does this power controller know that NEPA is available, or the generator is available? Is when there's a signal here, then there's going to be a signal here. If there's no signal here, then there can't be a signal here, and this indicator is not going to come up. Do you get the point? So this is point. Do you understand it? We said this is going to require a phone module. Then what we said, and we, please, are you following me? Can I continue?
Yes, sir.
This is going to require a phone module. We said the phone module, don't forget, it's going to be connected here. Here the transmit of this goes to the receive of this, isn't it? Why the receive of this goes to the transmit of this? Does it make sense?
Yes.
And then we said it's going to have voltage that goes to 3.3 volts and one that goes to what? Negative of supply. Do you get it? So this is your SIM 800F to the pin 17 and 18 on the control. Does it make sense? You saw how this is connected. We have already discussed that before. Can I continue? That's how this is out. We have these three, and they are still looking at us here. Can I continue? I have already told you how this guy is connected. How is it connected? Assuming this is your pin 12. It goes through a resistor to a transistor. Are you with me? And I said this is a 1 kilo transistor. Resistor, isn't it? And I said the transistor is what? BC547. I gave it to you. I wrote it before. And I said that your relay has 2 points. Don't forget, it has a positive point and negative point. The negative point is connected to the collector of the transistor, isn't it? While the emitter of the transistor is connected to the negative of the supply, which is what the negative side of the diode of the relay is looking for, isn't it? While the positive part of the relay is connected to your 12 volt supply, DC. That does it. Now there is a diode there, a flywheel diode that is connected here. This diode is a 1N4007. So that when the diode or when the relay is de-energized, the voltage that the coil has amassed does not flow back through the transistor into the system. So it blocks the back EMF, electromotive force. Do you get it? I'm glad you understand that. Now, don't forget the relay is going to have a wiper, isn't it? Don't forget this is a common. We now say we have what? Thank you very much. The negative, normally close contact. We now have another contact which is normally open contact. Does it make sense? So you see the coil. So the way you see this coil connected is the way you have this coil, and this coil. So one part of the coil already has what? Positive of supply. The other side of the coil is connected to the collector of the transistor and through the emitter to ground. Do you get it? The question you're asking, which I've explained before, I'm repeating to you. So that when the base of this transistor is biased, the coil, which is the collector of the transistor, that is carrying the negative tag of the contactor, switches it to its emitter, already has the negative that this relay is looking for. What happens? The wiper moves from the normally closed contact to the normally open contact. And when this is de-energized again, what happens? This has like a potential divider, a potential high resistance across them. Then it returns, and then this one loses negative, and then the wiper returns to the normally closed contact. Does it make sense? Except that when this happens, two contacts are being energized on one particular coil. So you now have, the way it is now, you now have normally close contact 1, normally close contact 2. Do you get it? Normally open contact 1, normally open contact 2. Do you get it? And they are separated. This one is already sleeping again. So that what you now put on the wiper, you now have 2 wipers too. Don't forget, now common 1, now common 2. Do you get the point now? So that as one common 1 goes to the normally open or normally closed contact of 1, the common 2 goes to the what? Normally open or normally closed contact of the other one. Do you get it? That's how it's going. But understand that at every point in time, one of the relays coil is already connected to what? To positive. It's just waiting for the negative through this transistor. Do you get the point now? Just the way your load too is already connected, or at one point in time, just expecting the second one to switch it. Except that this time, in the course of the system, the live and neutral are withdrawn. You know before, when I draw that bulb here, we're only switching one, either the live or the neutral. But this time, you are switching both live and what? And neutral. So it's like having two switch or a gang switch. But it's not that those gang switch, they have different rays. It's like having this live neutral. So you have a switch here, you have another switch here. Do you get it? Do you get it? So when you enable the coil, what happens? The two lashes. Are you with me? So that live crosses to live side, neutral crosses to neutral side. And when you remove the coil, what happens? They are open again. So that's a gang effect, which means it's happening the same time. It's not like maybe if you close light, you don't close neutral, there's still no light. If you close neutral, you don't close light, there's still no light. The two must be closed, satisfied at the same time. Do you get it? That's why you have live neutral here, live neutral here, and live neutral here. Do you get the point? Sir? I'm glad you can. Do you understand it? I mean, that's the essence of the class. Do you understand? Does it make sense? So this is what you have on your pin 12, your pin 13, and your pin 14. The way it is wired is what differs. Which is what we had explained here.
This one is different from the other.
These two. Even though the result of these two gang enters into this place and comes out here. Do you get it now? Does it make sense? Alright. So that is set. Now, if you want to hunt any of them, it's the same thing. When you want to hunt NEPA, the one for NEPA, just say _AI pin _C1. Do you get it? If you want to hunt the enable, _AI pin _C3. Do you get it? And when you want to off it, you just have to put what? A low on that particular pin and it goes off. Those are the instructions for putting it on and off. Just the way you have the relay. This is application. Does it make sense? It makes sense? Can I continue? Now, the last guys that are remaining is the valve and your crank. Now, I need to explain this part before I close for the day. How does your crank and valve work? Sir?
Involves the generator.
That involves the generator. But this is the way it works. For a DC generator to come on, there are some two things that need to be satisfied. Let me explain it to you. Now, your DC generator is going to have a battery. Are you with me? Yeah. It has a 12-volt battery. The battery has positive, battery has negative. There's now something called, it has a valve. That valve is where fuel flows through. Assuming this is the tank. Are you with me? There's now a liquid valve that connects from here into the engine. I don't know whether it's the engine, but it's through the engine. That valve has a positive and a negative side too. So that if the valve is not enabled, you know the way the valve on your tire does. Yes. If you don't press it, air cannot come. IV, so it locks up. So when this valve is not enabled, it locks up. It blocks up. It doesn't allow fuel to go from the engine, from the tank into the engine. When you enable this valve, what happens? It opens up and fuel can flow. Now, the way they've done it, they've taken the negative of the valve to negative already. The positive of that valve is just waiting for what? Positive. But that positive is being switched through a relay. The relay is always there. It's always there. So it's switched through a relay. So it's positive that it's waiting for. So by you bringing positive to that part of that relay, what you are doing is that when the relay is energized, which you call the coil of relay is energized, what happens? It flips voltage that's already available. They've wired it already, just the way you saw me wire it here now. The relay is wired to the valve, to the voltage of the valve, and then the valve opens up and then fuel begins to flow. The moment you withdraw that voltage, are you with me? The relay loses coil voltage and then the valve is off again. So fuel cannot flow. So before you can actually even start the generator first, you need to therefore on the valve. So it is when the valve comes on that you can then go and crank. It's like starting your fuel generator, your petrol generator without, even if it starts temporarily, after a while it will go off. Are you following me now?
Yeah.
So that is why if you look at it, for your valve, you are going to need a relay. Wiper, normally open contact. Is the two things you need. What are you putting there? Put battery voltage here. Put this one on the other side. As simple as that. Do you understand what I just did? If this was the relay, look at it. Plus 12 volts. The negative. Are you following? Look at here. Normally close contact. Normally open contact, wiper. So what do? Put battery positive here and put this one to the wall, to that positive of the valve. So the moment you switch, this place just closes. That's all. Battery is there. And then the valve opens and then. So after the valve has opened, the next thing you're not going to do is to do what? Crank. The same way this is connected. Don't forget, for the crank, it's the same thing. For the crank, there's this shaft that needs to turn. Are you with me? For the system to start, for the generator to start. It's called flywheel. On the flywheel is another DC motor with teeth, such that when the teeth comes on, it spins the flywheel and then the flywheel can then start the engine and go. And the moment the flywheel has started rolling, the tooth returns, the crank returns, because the flywheel is already running, is doing its job. Now, that crank is actually a DC motor. Are you with me? That DC motor is what you are energizing. Now, that DC motor has 3 contacts. It has the positive, it has the negative, it now has a switch. Are you with me? That switch is also is supposed to connect to the positive. So when you take that switch to the positive, it does boom. When you move the switch voltage, it goes up. So simply what we are doing here, instead of now positive of battery and the valve, it's now going to be positive of battery and what? And the switch. Do you get it?
It's like positive connection of the
valve.
Non there is a switch that is being connected.
But to understand, don't forget there are 2 now. So 2 different relays. But to understand that the moment it starts for about 3 seconds or 4 seconds, you are supposed to do what? You're supposed to stop. But that valve must remain on. If it is when the system tries to start the generator does not start, that's when it then goes and off the valve. But the valve should not be on if the generator is not running. We don't need fuel flowing into it if the generator is not running. Are you getting my point now? Now, but the moment the generator starts and the crank stops, that valve must remain on. If you now want to off the generator, all you need to do is to do what? Off the valve. It closes, the generator requests for fuel, fuel no day, it goes up.
Did the gen go off instantly like that?
Instantly.
Like petrol gen.
And for petrol gen, it will still burn up the liquid that. Diesel will go up almost immediately. And let's be frank. How much is immediate? It can be up to 60 seconds. Now, even if it does not go off, the system is not very much concerned about it going on and off. The first thing it does is to put off its relay to the load and switch NEPA's relay. So even if it is there, it's not using it. They are not mixing. You have NEPA, which is automatic or instantly, and then generator can go off anytime it takes it to go off. But as long as that valve is closed, it will definitely go off. So that's all.
Yeah.
How to confirm it?
Please confirm, sir.
The signal that is coming out from the crank, like the signal just runs for a few seconds, like
4 seconds. 3 to 4 seconds. Yes. It is not signal, it's voltage from the battery to the starter switch of the starter motor or the motor starter. Yeah, that's what it's connected to. That's what you are calling crank. It's not crank, it's a starter motor. So you are calling it starter motor, you're calling it crank. It's the same thing now. And stop. It's just nomenclature.